Okay, thank you and welcome back to our YouTube channel. In the previous coverage, we covered unbiased estimators and we looked at what unbiased estimator stands for. So today we want to look at efficient estimators. Efficient estimators. Let T1 and T2 be two unbiased estimators for the same parameter theta. If the variance of T1 is less than the variance of T2, then T1 is said to be more efficient estimator than T2 for theta. The relative efficiency of T1 with respect to T2 is given by E is equal to variance of T2 over the variance of T1, which this one should be greater than 1. So under efficiency, we want to compare two estimators which are unbiased. I remember you know what unbiased estimator means. If not, go to our previous video and look at what we discussed about the unbiased estimators. So in terms of estimators, an efficient estimator, we compare the variance of two unbiased estimator. When one of the variance of one of the estimators is less than the other, then the one which is less is said to be more efficient than the one which is larger or more. So this is our case. If the variance of T1 is less than the variance of T2, then T1 is said to be more efficient estimator than T2 for theta. Then for us to find the relative efficiency of T1 with respect to T2, this is given by E is equal to the variance of T2 divided by the variance of T1, which is more than 1. It's more than 1. Let us look at an example. x1, x2, and x3 are independent sample values from a Poisson distribution for a parameter m. You know what a Poisson distribution means? The mean and the variance are the same. So T1 is given by the first estimator. T1 is x1 plus 2x2 plus 3x3 all over 6. And T2 is given by x1 plus x2 plus x3 all over 3. Find the efficiency of T1 in relation to T2. Find the efficiency of T1 in relation to T2. So we have two estimators there, T1 and T2. So in terms, for us to get the efficiency of T1 in relation to T2, we look at the variance of T1 and the variance of T2. This is the solution. Variance of T1 is equal to the variance of x1 plus 2x2 plus 3x3 divided by 6, which is the same as 1 over 36. This is 1 over 6 inside the bracket there. So when it gets out, when we spread the variance inside the bracket, then that 6 comes out as a squared value. So it becomes 1 over 36 bracket variance of x1 plus this 2x2 becomes 4 variance of x2 plus 9 variance of x3. 9 variance of x3. The 2 is squared, also the 3 is also squared. So our answer there becomes 1 over 36. The variance of x1, because it's a Poisson distribution, it remains to be m. Plus 4, the variance of x2 is also m, and the variance of x3 is also m. So 1 over 36 in bracket m plus 4m plus 9m. We have 14m out of 36. M plus 4m plus 9 gives us 14. And so you're giving us 14m. 14 times 1 giving us 14m out of 36. That's the variance of T1. Let's look at the variance of T2. It's given by the variance of x1 plus x2 plus x3 all over 3. So here we'll have 1 out of 9 variance of x1 plus variance of x2 plus variance of x3. The variance of x1 is m, same to the variance of x2, and same to the variance of x3. So m plus m plus m gives us 3m. 3m times 1 over 9 gives us 3m over 9. 3m over 9. So our efficiency our efficiency is equal to the variance of T2 divided by the variance of T1. So we'll have 3m over 9 divided by 14m over 36. Our answer becomes 12 out of 14 as our efficiency of T1 in relation to T2. Thanks for your time, and welcome back to our YouTube channel.
Subscribe.
Don't forget to subscribe.